Welcome once again to this episode of solving these past WAEC questions. So here we are going to solve question number 29 from the past questions extracted from essential physics. So now look at the question 29 here. As you can see that this one here is a Wisto bridge. Look at what it's saying here. It says in the diagram above, the galvanometer indicates a north deflection. What is the potential difference between X and Y? Okay, now before you can be able to solve this question, you need to understand what Wisto bridge is all about and the working principle of this Wisto bridge. Now, what is a Wisto bridge? Okay, so let's go to the class. Let's go to the board. Now, when we talk about a Wisto bridge, so this question talks about what? A classical Wheatstone, okay, bridge. So this is a bridge. Now, the Wisto bridge is an electrical circuit which is used to determine an unknown resistance, okay? So a Wisto bridge is an electrical circuit used to measure an unknown resistance very accurately by balancing two legs of a bridge network. Now, what does that mean? When we talk about a Wisto bridge, it consists of 4 resistors arranged in a diamond shape. How does it look like? Now look at the question here. Look at how it looks now. Just view this question. So the center here is the galvanometer that will detect whether current is flowing through the circuit. This here could be a resistor, a non-resistor. This can also be a non-resistor, and this one is a non-resistor also. So now this R here, we don't know the resistance in this place. So that is why we need to balance this circuit. Let us check if this resistance will have the same value at this point X and this point Y this way. Okay. Now look at where we are interested in. What is the potential? Look at what is the potential difference between X and Y. Now, what is the working principle of this Wisto bridge? Remember, I said that it is used to determine the unknown resistance. Okay, for example, it's like this. Okay, let's say this is G. Now, you can have like this, like this, like this. So, like a diamond. And this galvanometer is what will help us to detect whether current flows. So if the galvanometer deflects, so here can be resistor 1, here can be resistor 2, then it can be resistor 3, and here is resistor X, which is the one we are looking for. Now the principle of this the Wisto bridge, is that the bridge works on the idea of no deflection. So when no current flows through the galvanometer, through this galvanometer here, so what does that mean? It means the bridge is said to be balanced. So if the current does not flow, so the galvanometer will not deflect. So in that case, the bridge from the left-hand side here, look at the bridge from the left side, okay? So this is the left side of the bridge, and here is the right side of the bridge. So which is like we are in a state of equilibrium in physics, okay? So it means that this side here is balancing this other side. Why? Because there is no deflection from the what? The galvanometer. Now, what does that mean? In that case, what it simply means that what? The resistance, the ratio of the two resistance here will be equal to the ratio of the two resistance on the other side. So which means R1 over R2 equal to R3 over Rx. So what does that mean now? We want to get this resistance. This is our unknown resistance which we are looking for. Okay. Now we can cross multiply. If you cross multiply, we can have Rx, then R1 equal to R2 multiplying R3. Then you can get your Rx by dividing both sides by R1. We have R2, R3 equal to, okay, that's all over R1. So this is how this Wheatstone bridge is used to determine the unknown resistance by balancing the legs of the bridge. Okay, now back to our question. We are meant to understand that this galvanometer have a null deflection, and when there is null deflection, simply means that what the current does not flow through the bridge, and in that case the potential difference now becomes the same. So the potential difference at x here, this x here, let me use this diagram here. If here is x, let's call here point x. Okay, we can call this point x and call this what? Point y. Okay, so the potential difference here now will be equal to potential difference at this point, which means v of x equal to what? V of y. So in that case, it means that what? The current now will now be 0. Okay, so that is what it means. So Vx minus Vy, okay, equal to 0. So that is what this place is talking about. So the potential difference now between x and y is 0. So that is what is happening here. Okay, so I hope you understood the explanation of this question. So your answer here is 0 potential. So the potential difference at x is equal to potential difference at what? Y. So that is the answer to that WAEC question. I hope you find this class very interesting. If that is true, please help us to share this post so we can reach out to a greater number of students on this platform. God bless you. Bye.